So let us continue with the next part. Let's start working with our component that will actually be driving this behavior and making it happen. So we go to Blueprint class and add an actor component, BPC for Blueprint component, and then we'll call it visual selection. So we open that one up. And what we need to do now is we need to make a few functions to allow this to work. So the first thing we need to do is add a variable, and we'll call this active selected. And this will represent the thing that we have currently selected. And we want to have this type variable as an actor. So actor object reference, like so. Control and save. Now let's create some functions to allow this to work. So we're gonna have one function which will sort of trigger everything to start working. So create a new function, and we can call this one begin player visible selection. Like so. And from here we're gonna be getting owner. So that means the actor that owns this component. That's not what I intended to do. Then we want to cast this to a pawn, because it will always be a pawn that will be having this, because nothing else than things that we control are interested in highlighting things. And from this pawn we're gonna get its controller, and we're gonna be checking if this is valid. We want to have the other valid check, so we get some branches for our connections, like so. And from here we want to check, after we know that it's a controller that's valid, we want to check something else, and that is if this is a local controller. Because it should only be happening on a client. And after that we will do a do once, connect that, and after that we will do a set timer by function name. Now, very important thing to note here, make sure that you type in the function name exactly like you type it in here, or else your function will not actually be called. But the reason we're doing this is because we want to not have the functionality update on a tick, because a tick can happen very often. So we want to sort of limit how often this happens. So we're going to type in 0.1, so it happens at most 10 times a second. We're going to be clicking in looping to make sure that it continuously does this. And then we're going to name this function update selected, and then we're done here. So we can just add a return node. So now we need to create a new function which handles that which we just did. So we'll call this one update selected, and you can see it gets a space over here, but it doesn't have a space over here, and I didn't have a space over here, so that's so it will call on this one properly, and we won't have an issue. Now this one will do just a few things. It will do something first to see if it has a target, and then it will set that as active. So we're going to be making a few helper functions here. So the first one we're going to be calling find active, and the second one we're going to be calling set active selected. We go back to our update selected, and we drag in our find active, so, and our set active selected, like so. These, however, are not complete. They need to have an object. We want to have a variable returned from this, and we want to have one sent into this one. So we'll go to our find active, we'll add an input, make it of an actor type reference, and we'll call this one active. That's wrong. I don't want it as an input on this one, I want it as an output, so we'll do it like this. Active. And we go to set active selected. This one is getting it as an input. We'll call this one active as well. So now we go back to our update selected and can see that we now have our 2 pins here. So we'll just connect them like so. And that is done for now. Next, we're going to be adding some actual code to find out which one is the selected one. And this is going to be a little bit of code. So if we go to find active, and I'll explain this so that it will hopefully be clear to you, but we will start off by getting our owner again. And then we try to cast this to a third-person character. So, and then we're gonna do something that we're gonna be doing it even though it's not good, but I'm gonna explain to you why. We're gonna be doing a get actors with interface. And the reason this is bad is because find active will run every time we're doing update selected. And update selected is going to happen every 0.1 seconds, which means that this code here will run 10 times a second. I generally try to avoid teaching that people should use get all actors other than like in begin place or instances when they have to do it once. But we're going to be doing it here, and I'm going to explain why and how you can do this better. But we're going to not be doing it better this time simply because it's going to be taking too much time. The reason this is bad is because, or the reason we're doing this is, we want to have all the actors that we are able to select available to us. And this is an easy way to get all of those. But a better way to do that is just to do it at a begin play. The problem is we're now making it for multiplayer, which means that we could possibly have something like a map where people could drop in and out however they wanted, which means that we have to keep track of which actors are available. By doing this, we will always have all the available actors in the world that are actually implementing the interface we're interested in. But a better way to do this would be that this is contained as a list, and it gets updated every time someone gets either disconnected or connected, and then just checks that list. However, this is how we're doing it now. Hopefully you understood why this is bad, and if you want to do it better, you hopefully understood how you can make it better as well. Anyway, we're gonna get a result of actors from this. And now we're going to be doing some math. So what we're going to be doing is we're going to be taking... First we're going to be looping on them to begin with, to have all the results. And each of them we're going to be working with them. We're going to be needing some variables to be able to sort out which one is the interesting one. So we're going to make a local variable. We're going to call it local closest actor. Like so. Making another variable, we're going to call it local closest dot product. Product. So the locus closest actor is going to be of type actor. The second one is going to be of type float. And we're going to have a default value on the local closest product also as well. We're going to have it 0.9. And this value will be something that you set, that you want. This is going to be determining how accurate you be needing to aim at a certain player or character for it to be highlighted. So a 1 would be that you're straight pointing at them. A 0.9 means that you have some degrees of like pointing nearby them. And the lower this number gets to 0, then you basically just have to have them in an arc in front of you. Minus would mean that it would be somewhere behind you. So this is probably a good value, but you can play around with this as you want. So the result from this, we're going to be getting this actor's location. And we're going to get some other stuff here while we're at it as well. And then we're going to be going through why we get them later. But is actor being destroyed, we're going to have just as a precaution. And we are also going to be getting our owner again. And then we're going to be comparing this, this owner. I typed in a exclamation point, which is generally in coding referred to as opposite, an anti, a not. So this would be a not equal. So we're checking if this value that we're going through now is not us, because we don't want to check against us. We want to check against only other things. We want to check if this actor is not being destroyed. And then we're going to have a last thing as well, which is going to be a little bit more complicated. But for now, we're going to be typing in an and adding 3 pins and connecting the 2 ones here. So we want to make sure that the target that we are currently targeting is not being destroyed. It is not is not ourselves, and also fills the criteria that we're about to reach over here. And this is where the math comes in. So we're going to take our third person character over here, and we're going to get its follow camera. And the reason for this is we want to know, first of all, where it is, and we want to know where it is pointing. So we're going to get a world location, and we're going to get a forward vector, which is the direction that it's currently looking at. And over here we want to subtract, we're going to type a minus here. We're going to subtract some vectors here, but we want to subtract the actor location that we get over here with our world location of the camera. And then we want to normalize this, like so. And this is so that we get a direction from the world location to the actor location that we're currently comparing, and we're checking what is that direction like, and we're going to be comparing it with a dot product. So I've explained this in an earlier tutorial, but I'll go through it a little bit again. So we have a direction here which is pointing forward with the camera, and we're getting a direction by subtracting these 2 vectors to get a direction between these 2 objects. We're comparing these 2 directions with each other to see how aligned they are. The more aligned they are, the higher this dot product will be, up to a value of 1, just like this value we talked about here earlier. So something that you're pointing directly at has a value of 1, something that is on directly perpendicular or directly 90 degrees to either side of you would be a 0, something that's directly behind you would be a -1. So we get a dot product from this, and we compare this dot product. We check if this dot product is greater than our local closest dot product, so the one that we currently have calculated. It's going to start at 0.9, but this means that if we have multiple things that we're checking against, we're going to be taking the one that is the highest dot product, so the one that we're aiming at the best, so to speak. And this value is the value that we drag in as our last little comparison over there. And from here we're just going to be having a branch, like so. And we're going to be running the loop into that branch, like so. I think we can possibly clean this up a little bit. Something like that, maybe. And after we have done this, what we want to do is we want to, at this point we have established that this product over here is no longer lower than this, it's higher than this, which means that we need to set our local dot product over here to whatever value we had over here. That means that we have the best accurate direction so far. But we also want to keep track of which actor is this. So we're going to be taking the actor from the loop over here and set that in the cases where this is the most accurate of the hits. Like so, maybe. I think this will be better. Yeah. And that is more or less everything that we need to do here. So when we do a return now from here, we have an actor to give back, and the actor we want to give back is our closest actor that we've calculated over here. So that is all that this does. It finds the one that we're aiming at the best, and it returns that actor to us. So then we're sending, in our update selected, we're taking that result from there, sending it into our set active selected. So in our set active selected, what are we going to be doing with this? Well, we're going to be comparing this actor to see if it is the one that we have currently set as. Now this is the variable that's living outside, not the local variable that we had in the. Over here we had a local variable called local closest actor. It's not the same as active selected over here. But we're going to be comparing those two to see if they are the same at this point. So, because we only want to have a new, we don't want to do something if we're already aiming at that actor. But then we need to make sure, is this a valid actor? If it is a valid actor that we have currently, so at this point we're checking, are they different basically, because we're going to the false. Are they equal? False. And they are not equal because we're going down the false. Then we're checking, well, is the one that we currently set valid, which means did we have something here before? If so, we need to remove the highlight of that one because that one is apparently already highlighted. So we're going to be typing in remove highlight and hooking it up to the valid. If it was not valid, then we don't need to remove highlight of anything because it wasn't set. But if it is not valid, we still have our new active selected, and we need to set that one to be whatever we got in here as our active. So we're replacing whatever we had as selected before with what we're getting in here now. Like so. And we need to make sure that this one gets highlighted. So this should handle all the logic for the highlighting and removing and the highlight on all our objects in the world. And that is all we need basically for this. The very last thing we need to do is we remove this and we go into our third person character and we make sure that it actually gets this new component that we have created, so it has it available here. So now it has visual selection, so it's actually able to visually select in theory. We should be able to test this also if we just alt drag another character out like so. Play. That is not working. Let's see. We'll put in some breakpoints. We'll put one on the add highlight and one on the remove highlight. This is wrong. This one is removed. This one should be not set like so. And then we can set a... Let's see. We want to check when we have a valid... We want to set it over here. This is the point where we come to when we say that it's going to be highlighted. Let's check this. So we're aiming, nothing is happening. So it's not sending the messages. Right. I forgot the very important part of actually initializing. We made the function. Let's create a begin play here. And then we'll use our visual selection. and we'll drag out select begin player visible selection, this one. Because we need to initialize that it's actually going to start scanning for things. So by doing this, now running up here, we can see that it reaches this piece of code. We can remove this one, resume. You can see that it has been highlighted over there. And if we are not looking at it, it stops being highlighted. Now, there is something broken here because it didn't start highlighting again. So let's see if we can find the error for that. Remove highlights. Let's set one breakpoint here again. Should be highlighting twice, so let's do this. We'll go over here, get the highlight first, the remove highlight, going back we get no highlight. So something is wrong earlier here. Let's see. Let us try by going to find active and see if we have a problem over here. We can do a branch, I guess. We can check if this is a valid actor. Like so. Checking against that. So when this loop is completed, it will send both false and true to the return node. No, we'll do two separate nodes. We'll do it like this. Drag them both in here though. So if we get to this point and the local closest actor is valid, then we're getting a true, so we want to come here. So let's add a breakpoint there. Hopefully it's able to, I'm not sure if I've actually ever tried setting a breakpoint over here, but let's try it and see what happens. We play, we get a active variable here, we get third person character 167, resume, we set a highlight on him, we keep getting this one. Let's change the scanning time a little bit so I have the time to actually react. Let's say 3 seconds. Then we have to remember to change this back again. But for now, it's going to be fine, hopefully. So we're looking at him, we get a value. It's 167, we resume. It's going to highlight 167. That all makes sense. Going to look away. We come here. It's going to say it's still valid. That's unfortunate. We're going to have to look away a little bit further. Going to look back again. Coming here again. It says 167, which is good. And I'm gonna step out, we're gonna step into this one. So we have 167 here and we're comparing it to against our active, and our active one is set to be 167. That is not correct, because at this point we have come to the point where this is, I didn't follow through here now, but they were going to be equal. We're going to get to the true. So if we do this, after removing the highlight, we're setting the active selected. Let's try this. So we're looking at him, we're getting 167, I'm assuming. Yes, we're assuming, we're highlighting, it's fine, we're looking away. So removing the highlight, hopefully. Yes, we're looking back. Get a hit for 167 again. We're stepping into this one. And our active selective at this point now is none, because when we removed the highlight here, we removed the active we got in here then was going to be none, so we set it as none, which means that we're now going to be highlighting it again. So let's fix what we broke when we debugged. So we removed the breakpoints, we remove this branch. We don't need the branch. We don't need this valid. We only need this one. We don't need both return nodes. We only need one. And we can go back to our time here in begin player visible selection, set it back to 0.1. And now if we play, it should be, I'll remove this breakpoint as well, resume. Now it should be much more responsive. You can see that it's almost instantaneous because it happens every 0.1 seconds. So this works fine for our means. Yeah. That is all for this episode. Hope to see you in the next one. Keep on learning. Take care.